Now, in the last video, we treated types of salts and we talked about acid salts. I said acid salts are formed when all the replaceable hydrogen ion in an acid is partially replaced by a metallic ion from a base. For instance, I gave you an example of a base as sodium hydroxide reacting with an acid HCl, an acid like tetrasulfate 6 acid and a base, for instance, like potassium hydroxide. When these two react together, this will react with this will react with this. You get potassium sulfate plus H2O. In this case, I trying to balance the equation. You have 2 here. In this case now, this is a normal salt. I said if you have potassium hydroxide plus tetrasulfate 6 acid reacting together to give you KH, instead of all the potassium here replacing the 2 hydrogen, you have K. One of the hydrogen is replaced, remaining 1, and you see you have your tetrasulfate 6 acid, and then you have your 1 hydrogen here combining with hydroxyl here to give you water. This is an acid salt. This is an acid salt because of the presence of hydrogen. So this potassium hydrogen tetraoxosulfate 6. Instead of potassium tetrasulfate 6, this is a normal salt. This is an acid salt. So we also have a basic salt. How have basic salt formed? Basic salt contains majorly hydroxyl as part of, instead of acid salt containing hydrogen in its formula, a basic salt contains OH, that's hydroxyl, in its formula, and it is formed when there's an insufficient supply of acid which is needed for the complete neutralization of a base. Just like a metallic element from a base replaces one of the hydrogen of an acid. For basic salts, the hydrogen from an acid is supposed to replace the hydroxyl from a base, but when there is partial replacement, a basic salt is formed. I'm going to give you an example here. Hydrochloric acid reacting with calcium hydroxide. I'm going to write calcium hydroxide first to show that is what we are talking about, and hydrochloric acid. When these two react together, now we have 2 hydroxyl ion here because a base is an hydroxide or oxide of a metal. Now this is a weak alkali because it's soluble in water. Calcium oxide actually dissolves in water from calcium hydroxide and is weak. Now this hydrogen is one here supposed to take the place of this chlorine supposed to take the place of hydroxyl now, but only one of the hydroxyl will be replaced. So a basic salt is actually formed when all the hydroxyl ion in a base is partially replaced with a negative ion from an acid. Now let's split this. This is supposed to combine with this to form calcium chloride, but instead of 2 chlorine replacing the hydroxyl here, only one of the chlorine will replace it. So we have Ca. Instead of these 2 hydroxyl, you have OH1, then Cl plus H, then the OH, one of the hydroxyl that leaves here, combine with this H to form H2O. So in this case, this is a basic salt because of the presence of this hydroxyl. This is a basic salt and you won't have your H2O here. Now this basic salt is called calcium hydroxyl chloride, and it can still undergo further reaction to form a normal salt. By reacting with hydrochloric acid, it can form a normal salt. Take for instance now, one of this chlorine, the last chlorine here, still replace the remaining hydroxyl. You have CaCl2 plus H2O. So this is a normal salt, while this is a basic salt because of the presence of the hydroxyl. The next types of salt that we are treating is the double salt. We have other example of basic salt. Actually, we have magnesium hydroxyl or trioxonitrate, which later form magnesium nitrate when all the hydroxyl ions are completely replaced. The two here, the two is okay, so you have N2 outside. Now let's look at double base. In double bases, double salts rather, sorry for that. In double salts, this is usually formed by dissolving 2 or more salts, up to 3 salts in water actually, to give different ions, 3 different ions. 2 of these ions are positively charged, while the remaining one is negatively charged. And so you have a structure like maybe X. Then the first element there should be monovalent, while the second element should be trivalent. Then you have a negative radical there, dot any water of crystallization. You get a double salt by dissolving 2 or more salts in water, and they are usually collected or crystallized out using fractional distillation method. Now I'm going to give you an example here. I said a double salt is formed by dissolving 3 different salts in water. By dissolving salt in water to form different ions in water. I'm going to give you an example here. Okay, we have ammonium ion tetrasulfate 6 dot hexahydrate. This ammonium actually usually have +1, so ion in this case is +3, tetraoxosulfate 6. The 2 here comes here, while the 2 comes here, while the 3 comes here, dot 6H2O. Another example is potassium. Potassium has 1 valency, aluminium has 3. Sulfate is the third one, which is negative, SO4 2 minus. Now this comes here, while 3 goes to the other side, and then you have dot H2O. Another example, dot 12H2O, dot 12H2O. By the time we react this together, we have 2 coming here, 3 coming here, and then we still have K, Al, SO4, 2 comes here, 3 comes here, and so in this case now we have potassium, aluminium. This is positive, and this is negative. A double salt has 2 positive ions, 1 negative radical, and a water of crystallization. So this is usually formed by dissolving different salts. For instance, now we can dissolve, for this compound we can dissolve potassium tetrasulfate 6 and aluminium tetraoxosulfate 6. When this is dissolved together, then you get this double salt. This double salt is usually formed. You can have different ions in water because this is common. This is common to them all. You have something like this: K, Al, SO4, because SO4 is 2. We dissolve this and this compound in water, aluminium sulfate in water, you get this dot 12H2O. Now these are examples of double salts. You can see 2 different positive ions and 1 negative ion, and the last one is the complex salts. In complex salts, a complex salt is usually made up of ions. You see ions on it, and the ion represents, the ions is for all the atoms inside the brackets. It's actually made up of a complex ion. That's what I'm trying to say. Now take for instance, we have tetraamine copper 2 ion, in which copper is the central element surrounded by ligands, which is amine, ammonia, and the ion there is +2. Here you have copper, this is what we call a complex ion. We have tetraamine copper, tetraamine copper 2 ion, because of the 2 as the net charge. We also have potassium hexacyanoferrate 2, which is K4 FeCN. Now this 6 is hexacyanide, is CN, carbon and nitrogen, cyanide, hexacyanoferrate, while this is potassium, to form a complex salt of that nature. We call it potassium potassium hexacyanoferrate, ferrate 2. This is a complex salt, not a double, because iron is at the center and is surrounded by cyanide and potassium. So these ones are acting as the ligands, while this is a core element. The same thing here, this is a core element, while these amine are standing as the ligands. Now, having described the types of salt, we've described the normal salt. Totally, the hydrogen ion in a salt is totally replaced. The hydrogen ion in an acid is totally replaced by a metallic ion from a base. A basic salt, the hydrogen ion in the acid is the hydroxyl ion in the base is partially replaced by a metallic ion by a negative ion from an acid. Then we have the double salts, the complex salts, and the acid salts. Now these are the types of salts. How are salts formed? There are 2 salts to describe here. We have the soluble salts and the insoluble salts. Most of the soluble salts, the normal salt, that when they are formed, you won't see them. When you add acid and base together, a salt will be formed, but you will not see the salts formed. So that's neutralization reaction. The salt usually dissolve in water, and then by the time you heat it to dryness, you will get your salt out. Those ones are common commonly prepared by neutralization reaction, that occur when you add an acid to a metal or you add acid to a thiazocarbonate. The salts you get in this case are what they are soluble in water. All you need to do is to heat them to dryness. While the insoluble salts, those ones you have a special way of getting them. Number one, we can use double decomposition method to get the insoluble salts, and then we can use combination method, direct combination. I'm going to treat this in the next video, but before that we'll round up this class by describing the uses of some salts. Ammonium chloride is a salt, for instance, now, which is formed by maybe ammonium hydroxide and sodium chloride, for instance. Now we get anhydrochloric acid. We can use ammonium chloride in as washing powder, and we also use it as electrolyte in dry cells in batteries. Calcium thiazocarbonate 4, that's CaCO3, is used as medicine to neutralize acidity in the stomach. That's the we use it as Cas-Mag or as part of Mix-Mag, but it's not a Mix-Mag, but it's also used to neutralize acidity in the stomach. Calcium chloride is used as an antifreeze. Then we have fused calcium chloride. That one is in dried form, is used as a drying agent. We have the calcium tetraoxosulfate 6, which is used as a plaster of Paris. That's CaSO4. We have copper tetrasulfate 6, CuSO4, that is used in dyeing and printing, calico printing. We have magnesium tetrasulfate 6, that's MgSO4, is used as Mix-Mag, if you've heard of that before. Also is used as a laxative. We have potassium trioxonitrate 5, that is used for making gunpowder. Trioxonitrates are explosive, making gunpowder and matches, and as also a soil fertilizer. Potassium trioxonitrate 5, because it's a source of nitrogen, so it's used for making gunpowder, matches, and soil fertilizer. Sodium chloride is used for preserving food. That's the sodium salt we use at home, and it's used for preserving food and glazing poultry, while the zinc chloride is used in petroleum refining. Then we need to know the salts that are soluble and those that are not soluble. That leads us to the solubility rules. We have all the sorts of sodium, potassium, and ammonium. That is, whether it's ammonium sulfate, or if it's ammonium sulfate, ammonium chloride, ammonium nitrate, and so on and so forth. Sodium chloride, sodium sulfate, sodium nitrate, etc. All these ones. Then potassium, the sort of potassium, chloride, nitrate, sulfate, and so on and so forth, they are soluble in water. Then all chlorides like barium chloride, magnesium chloride, calcium chloride, zinc chloride, copper chloride, mercury chloride, and so on, they are what? They are soluble in water, except that of lead and silver. Lead is soluble in hot water, and silver is not soluble at all. Silver chloride and lead chloride, they are not soluble. All tetraoxosulfate 6 salts too are soluble, like barium sulfate. All tetraoxosulfate 6 salts except that of lead sulfate, PbSO4, barium sulfate, calcium sulfate. Those ones they are not soluble in water. Calcium sulfate is slightly soluble in water. All other tetrasulfate 6 are soluble except that of lead and barium, and that of calcium is slightly soluble. Lastly, all thiazocarbonates of sodium, potassium, and ammonium are soluble. Since I said all sorts of sodium, potassium, and ammonium are soluble, like also all the thiazocarbonates too, maybe sodium carbonate, ammonium carbonate, 2 comes here. I think I've written that before. And so on. Potassium carbonate. All sorts of sodium, potassium, and ammonium are soluble in water, whether it's their sulfate, their chlorides, and so on. They are soluble in water, while other triazocarbonates are not soluble. So this will lead us to the next video, which is on preparation of salt and properties of salt.